lesson 11.4, we're going to simplify rational expressions. Who remembers back in elementary school when you used to simplify fractions? For instance, we could take 2/4, and what would we reduce 2/4 to? Vincent?
1/2.
1/2, because I divided each of these by what? 2. I reduced both of those numbers by 2, and that's how I got this fraction, by taking something away or dividing something out. What we're going to be doing today is we are technically just reducing fractions. However, the fractions in this lesson have letters. So if you listen and pay attention, you should understand it. But just keep that in mind. We are always reducing. So let's look at this first fraction here. 5x over 25. Now I see a letter in there, but I'm not really going to pay attention to that letter right now. I'm only going to focus on 5 over 25 because that's doable, right? We know how to reduce 5 over 25. What could I reduce those numbers by? 5. So 5 divided by 5 is 1. 5 divided by 25 is 5. Now I'm going to look at the x and I'm going to ask myself, is there another x for this x to cancel with? No, there's not. So he stays right where he is, and my answer is 1x over 5. Now, if you would have just written x over 5, that's okay also. You don't have to write that 1. So that would be my answer. That's all we're doing is just reducing fractions. But let's look at this next one. And these are mainly the ones that you are going to see in these next few lessons that we are going to do. I want everybody to take a look at this part of my fraction right here, x plus 5. Now this is where you really need to pay attention. X plus 5 is a part of what we call a family. A family are two terms joined by a plus or a minus sign. So that x and that plus 5 are joined together and they cannot be touched. Okay? I cannot cancel out these x's. I can never break anything apart from the family. Okay? If you memorize that, you will do fine on this lesson. It's people who forget about the family and they just go crossing out things all over the place and then they get the wrong answer. So a family is any set of terms that are joined by a plus or minus sign. So I have a family right here, I have a family right here, and I have a family right here. All of these terms are joined by plus and minuses. So right now, this family, I know I cannot touch it. So I'm just kind of going to color over it. Y'all don't do that on your paper. I'm just doing it for right now because I'm not even paying attention to it because I know there's nothing I can do to reduce it. So I'm just pretending like it's not even there. And I'm just looking at what I have left. 2x over x. Is there something that you see we can cancel out? What is it? The x's. So I'm left with 2 over, what's on my denominator? X plus 5. This is my final answer. Now, you can put parentheses around your family, or you don't have to put parentheses around your family. It doesn't make your answer right or wrong to have parentheses. I like to put parentheses to remind myself it's a family. I can't touch it. That kind of is like my little red flag for me. When I see parentheses or put parentheses, I remember. So you can if you want. You don't have to if you don't. Okay? So let's look at the next problem. What do you see? A family. Mary, what is my family?
X squared plus 6.
X squared plus 6. So this family is totally off limits. Let me show you what the biggest mistake people do is they go, ooh, x squared, cancel that out. That's gone. No, because the x squared in the numerator is part of the family and cannot be touched. So let's look at what we're left with. X over x squared. Now I'm going to show you an expanded version of this because sometimes this helps to see this the first time. I have an x on top, which just means I have one x. But I have an x squared on the bottom. What does that mean I have? 2 x's. So when I go to cancel these x's out, I can cross out 1. So I'm left with x squared plus 6 on the top and just 1x on the bottom. Could I cancel out these x's right here now? No, because what is x squared plus 6? Family. This is my final answer. Okay? Look at the last problem. What do you see? A family. Now, this family doesn't have parentheses around it, so I'm going to put the parentheses around it just because I like to. Is there anything here that's outside of the family that can be canceled out? Nope. So guess what? This is my final answer. Just like that. There's nothing I can do to this. Okay? So on example number 2, we're going to get into these a little more in depth. We have to reduce. Look at the first problem right here. 15x over 5 minus 10x. What do you see right off the bat? A family. What is the family?
5 minus 10x.
5 minus 10x. And I know, okay, well, there's nothing outside of the family, so I cannot cancel out. But here's the thing, and we didn't talk about this on the last slide because I wanted to wait till this one. Anytime you see a family, you should automatically ask yourself 2 questions. Is there a GCF of the family? Or can the family be difference of 2 squareds factored? Okay? Because a lot of times we're going to have to pull something out of the family so that I can reduce a fraction. So look at this. Does this family have a GCF?
Yes.
Yes, it does. Now I'm going to do the chart to show people how to get the GCF just for this first one. If you already know the GCF, that's fine. You can write it. But I just want to show you. In order to know what the GCF is, I'm going to write all the factors of the terms that I have. So the factors of 5 is 5. The factors of 10, I could do upside down division to find that, 2 and 5. So I line up the 5 underneath it, then a 2 and an x. So what do they both have in common? The 5. So I'm going to pull my 5 out for my GCF. Does this 5 disappear? No. Where does the 5 go?
In front of the
Very good. And then what am I going to do to everything in the parentheses?
divide by 5.
Divide by 5. 5 divided by 5 is 1. 10x divided by 5 is 2x. Well, yeah, negative 2x. So there we go. Now I've still got a family, right? 1 minus 2x. But I've pulled something outside of the family, so now I can reduce this fraction. What is fair game to reduce?
The outside number.
The outside number. What number can go into 15 and 5? 5. 5 goes into 5 one time. 5 goes into 15. 3. So I'm left with 3x over 1 minus 2x. You say, wait a second, I thought that was supposed to be in parentheses and a 1 out there. You can do that, but you don't have to. It's not going to change anything. This is my final answer. Could I cancel out these x's if I wanted to?
Nope.
Nope. Why not? 1 minus 2x is a family. Cannot touch it. So in the next problem, what do you see right off the bat? A family. What is the family?
2x squared minus 6x.
Very good. Now, with this family, I notice that right now, this problem as is, I cannot do anything to. But what do I ask myself when I know I have a family?
GCF.
Can I have do I have a GCF? Or there's one other question that you might want to ask yourself is it the difference of 2 squareds? So this one is a GCF. What is the GCF here? 2x. Very good. So I'm going to divide each of these terms by 2x. Again, you can find that GCF by doing that chart that I showed you how to do on the last one. 2x squared divided by 2x is x, or 1x. negative 6x squared divided by 2x. I'm sorry, negative 6x divided by 2x is negative 3 over 6x squared. Now, did I free up something to be simplified? Yes. 2 and 6 can be reduced to 1 over 3. How many x's can I cancel out? 1, and I'm left with 1 on the bottom. So on the top, I'm left with x minus 3, and on the bottom, I'm left with 3x. Perfect! I can now cancel out the 3's and the x's, and my problem goes away. No! Why not? Because x minus 3 is a family, and I cannot break them apart. Now look at the next example that we have here. Go a little more in depth. Your brain should have a siren going off because you see 3 terms and you know I need to factor. Very good. So I'm going to do my regular factoring. I'm going to make the x, put 1 up top, negative 20 on the bottom. What are the factors of 20? 1 times 20, 2 times 10, 4 times 5. Which ones subtract to give me 1?
4 and 5.
What are 4 and 5 signs?
4 is negative and 5 is positive.
Very good. Why is that, Valentina?
Because negative 4 plus 5 equals 1. And if you multiply negative 4 and 5, they equal negative 20.
Perfect. What do I need to do to the denominator? Same thing. So I'm going to make my x. 2 on top, negative 15 on the bottom. Factors of 15 are 1 and 15. 3 times 5. Which ones do I choose?
3.
What are their signs?
The first one.
Negative 3, positive 5. So I write x minus 3, x plus 5. Now you say, hold on a second. We only have families. I thought I'm not allowed to touch a family. And you're right. You're not allowed to pull families apart. But do you see any identical families? Yes. We can cancel out a family as a whole because they go away together. Okay? So, x plus 5 can cancel out with x plus 5. And I'm left with x minus 4 over x minus 3 as my final answer. Now, this is what I need you guys to know about these problems here. You're not going to have me on your test and quiz saying, okay, you see a family. Do you think you need to take out a GCF? Do you think you need to factor? Is it the difference of squares? So you've got to become very good at recognizing those things. So what I'm going to do for this next problem is I'm going to let you tell me what you see that needs to be done. So I'm going to stay quiet, and I want you to tell me step by step what I should do. So here we go. Somebody tell me what I need to do first. Valentina?
I see a factoring on the denominator.
Okay. And factoring on the denominator. Perfect. She noticed that right off the bat. So I'm going to do my x, 5 up top, negative 6 on bottom. Factors of 6 are 1 and 6, 2 and 3. Which factors do I choose, Vincent?
The 1 and 6.
Perfect. And why did you choose 1 and 6? Why not 2 and 3? Because they give me 5.
Because C is negative, so you have to subtract to get.
Perfect. We got to subtract the numbers to get 5. So which one's positive, which one's negative?
6.
6 is positive, 1 is negative. So in my denominator, I've got x minus 1, x plus 6. Okay, Mary?
You do the GCF for the numerator.
Perfect. Notice the numerator. It's a family. So I ask myself, is there a GCF? Yes, there is. What is that GCF?
X.
X. Perfect. Why is it not x squared?
Because x squared cannot go into x cubed properly.
Well, look at this part right here. How many x's is this term? 1. Could I possibly take 2 x's out of that? No. That's why my GCF is only an x. So then I'm left with x squared minus 1. Where did I get that from? I just divided each of these by that GCF. Again, I'm going to stay quiet to see if you know what to do now.
Oh, crap. That's the final answer. Thank you.
Are these identical? Are they identical families so that I can cancel? Mm-mm.
So you're
Oh, you can do the distributive property.
No, not distribute property, because that's going to undo everything I just did.
Factor.
They distribute something.
Fact.
What did you say, Vincent?
Difference.
Difference of squares. Where's my difference of squares? X squared minus 1. What's x squared square root? X. What's 1 square root? 1. Remember this. This will help you as you go throughout this section. Whenever you think you're at the end, always ask yourself, can it be factored more? GCF, difference of squares, regular factoring. If the answer is yes, you got to keep going. We cannot stop. So what is the difference of squares? X, X, 1, 1. What are my signs?
One's addition, one's subtraction.
Then I have X minus 1, X plus 6. Whoops. Then my X minus 1s cancel out. Now, with the, well, let me tell you your final answer. X times X plus 1 over X plus 6. With the exception of that last problem in the first example where nothing canceled out, you will always have something that cancels out. I'm not going to make you do all this work to get to the end and say, oh, nothing cancels out. Because that's the whole point of these, is to break them down and to simplify the most possible that you can simplify. So if you get to the end of something and you see, like right here when we got to this step and you saw, okay, nothing cancels out, then odds are that means you need to go a step further, because usually something will always cancel out, okay? So then example number 3, recognizing opposite factors. Now this is where I really need you to stay with me, because if you've tuned out, it's time to tune back in, because we're going to need to use our brains. We're going to need to use some logic, some reasoning. I know that you all have that in you, and so we're going to do that. First of all, I'm going to stay quiet, and I want you to tell me what you see that needs to be done. Vincent?
Factor.
Okay, which one? Numerator or denominator?
Denominator.
Denominator needs to just be regular factored. So we do our x, negative 1, negative 2. What are the factors of 2? 1 and 2.
And then 2 would be negative, 1 would be positive.
Very good. So x plus 1, x minus 2.
And then we bring the numerator over.
Yeah, you could do the GCF. Or, the squares.
Very good. Difference of squares up top. You say, but wait a second, Miss Reber. The problems that we normally do have the x squared first and the number last. It's okay. As long as they're both square roots, it doesn't matter what order they're in. But this is what matters. When I do the difference of squares, whatever is given to you first in the original equation has to be first in your parentheses. So what's the square root of 4? 2. What's the square root of x squared? X. And it's going to be plus minus. You cannot write x plus 2, x minus 2. If you do that, it is wrong, because you have to write it in the order that they gave it to you in the original problem. Now look at what we have here. Do you see anything that is identical?
Yes.
No. There's nothing that's identical. There's something that's very similar, 2 minus x, x minus 2. But let's take a second and just look at each individual term. This 2 is positive. This 2 is negative. This x is negative. This x is positive. So they're very similar, but they are the exact opposites. So what can we do with that? Can we still simplify? Yes, we can. And this is how. Whenever I find opposite factors, that means both of the factors are opposite. One's positive, the other one's negative. One's negative, the other one's positive. I can cancel them out, and I'm going to give you the short definition first, and then I'm going to explain why. This is what you do. Are you ready? Whenever you see opposite factors, you cancel them out and leave behind a negative 1. Cancel them out and leave behind a negative 1. You can do it on the numerator or the denominator. It does not matter. You say, okay, why is that? Why don't I ever leave behind a number on any of the other ones? This is the long version of why. Technically, when you have opposite factors, you have the same thing as long as you can factor out a GCF of negative 1. You say, okay, so let me show you this. 2 minus x. If I have this term, and I factor out a GCF of negative 1, well, 1 can come out of any number, and it doesn't actually change the number, right? But negative 1 does what to every term? Change its sign. Ooh, that's what we need, right? So we would put our negative 1 and divide each of these by negative 1. Or I'm sorry, we should put the negative 1 over here. And I get negative 2 plus x. Now, does this make this the same as this? Negative 2, positive x? Yes. That's why we cancel it out and leave behind a negative 1. Does that make sense? So you say, all right, how do I write my final answer? Well, I'm going to move this 1 to the front because anytime you have something that's being multiplied, you always want to put it up front because if I put it in the back, it might look like it's being subtracted. So I'd write negative 1 times 2 plus x over x plus 1. And that would be my final answer. So on the last problem here, we're going to do the exact same thing. I want you to tell me what you see that I need to do.
You need to factor?
I need to factor the numerator. So negative 6 up top, 9 on bottom. What are the factors of 9? 1 times 9, 3 and 3. Which ones do I choose?
3 and 3. They're both negative.
Very good. So we're going to write x minus 3 over what?
3 minus x, 3 plus x.
Perfect, Vincent. And what's that called? 3 minus x, 3 plus x. Difference of squares. Very good. All he did there is I noticed that both of them have an exact square root. I wrote it exactly the way that my original equation states it. Now, in this example, I've had a lot of people say, everything is opposite. No. In order to have opposite terms, they've got to both be subtraction. So, because this x is positive, that x is positive. Those aren't opposites. So even though you say, well, they have opposite signs, but that doesn't make them opposite factors. So when I have opposite factors, x minus 3, 3 minus x, I cancel them out and leave behind a what? Negative 1. Do I leave it on the top or the bottom? Either one. Doesn't matter. I like doing it on the top. So negative 1, x minus 3 over 3 plus x. Any questions? Okay, go ahead and open up your books, and this is the classwork that we're going to do today. Page 667, 10, 12, 14, 20, and 22. So it's all problems are evens.